Hi everyone, I am making a video today about the Pythagorean Theorem. First thing that you need to know about Pythagorean Theorem is that it is only going to be useful with right triangles. That is the most important thing to know, because sometimes in the future you're going to be given triangles but they are not right triangles, in which case you cannot use any of this. Now, what a right triangle is if you have a triangle where one of the angles is a right angle, or 90 degrees. It's the straight up and down, the straight over makes a perpendicular line which is 90 degrees. And that is a right triangle. Now, it doesn't matter if the angle is over here. It could be like over here. Sometimes they're shaped like this. But no matter what, one angle is 90 degrees. And that's the little symbol for 90 degrees that they use. So that's it. It is only going to be useful, the Pythagorean theorem, with right triangles. So before we get to actually using the theorem, I do need to talk to you about the little vocab of legs versus a hypotenuse. So in a triangle, there are three sides and a right angle. Whenever you are looking at a right angle, the two sides adjacent to it, next to it, are called legs. And then the third side that connects the two legs is called the hypotenuse. And that's the vocab right there. The two legs are next to the right angle and the hypotenuse is opposite. One of the big things this year through next year's is being able to tell which one the hypotenuse is and which one the other two legs are. That's always going to be the first step. With the Pythagorean theorem, you say, is it a right angle and which one's the hypotenuse? That's always going to be your first step going through all of those. And like I said, it can sometimes be oriented a different way. Like this one we did, this would be the leg, this would be a leg, and this would be the hypotenuse. Over here, since this is the right angle, this would be a leg, this would be a leg, and that's the hypotenuse. And once again here, this is the right angle, so right across from right angle has got to be the hypotenuse, which means the other two sides are legs. And that's very important to know. To go a little more specific, in math, when we are talking about a right triangle, we tend to call the sides A, B, and then the hypotenuse is C. And I do want to write that down, that C is the hypotenuse. Once again, very important. C is always going to be the hypotenuse. Technically, I could switch the other two. I don't really care about that. I could put the B here, the A there, but C does have to be the hypotenuse. That is going to make a difference in the formula that we will be using. So A and B can switch, that doesn't matter because they're both legs, but C is always the hypotenuse. So always make sure that when you're labeling that C is the hypotenuse. So the first thing I want to do in this is just to make sure you're getting used to that. I'm going to just put up a couple of practice problems for you guys. And I'll put up a problem, you pause it, you see if you get it, and then, you can move on. As soon as my pen works, boop, boop. And let's do this one like here. So I put up three problems. All I want you to do is, say which ones are the legs, which ones are the hypotenuses. And once again, I'm just going to go over it in about 5 seconds, so just go ahead and pause before I do that. Here you go. For this first one here, this one's a leg, this one's a leg, this is the hypotenuse. In this one, this would be a leg, this would be a leg, that would be the hypotenuse. And over here, hypotenuse, leg, leg. And once again, just make sure you know, C is going to be the hypotenuse. That's the one that's labeled. The other ones don't matter. I could do AB, I could do BA, I could do AB, whatever. It doesn't matter. But the legs are going to be A and B, and the hypotenuse is C. Okay, so hopefully you got all those right. If not, you can go ahead and rewind, and hopefully it'll make sense the second time. Next up, the actual Pythagorean theorem. And what is it? So, here it is. The formula that everyone's been waiting for is a squared, also known as a leg squared, plus the other leg, b squared, is equal to the hypotenuse squared. So a squared plus b squared equals c squared. This is the most stereotypical formula that everyone seems to remember from high school. It's like, do you remember anything from high school? A squared plus b squared equals c squared? Yeah. It's a very popular formula. And it's a leg squared plus the other leg squared is equal to the hypotenuse squared. So as you can see, it does make a difference that c does have to be the hypotenuse. A and b can switch because mathematically, b squared plus a squared is actually the same thing as a squared plus b squared. You probably know this because, like, 2 plus 3 is 5, and 3 plus 2 is 5. So whether you have 3 and 2 or 2 and 3 doesn't matter. You can switch the two numbers, and you always get the same thing when you're adding. So switching the b and the a wouldn't matter, because switching the legs wouldn't matter. But it does have to be c is the hypotenuse squared. So as I said up here, your first step in all these problems that you'll have to do is to see which one the hypotenuse is, because that's the one that's going to have to be equal to. Okay, so for example, I will have this triangle, and this is a right angle, and this is 3, and this is 4. And this is the most stereotypical example you'll ever see in your life. It'll come up every year from now until you graduate. 3, 4, and you're supposed to find the last side. So first of all, you need to note that this is a leg, and this is a leg, and this is the hypotenuse. So we do not know c. I'll call this a and this b, because why not? In which case the formula now says a squared plus b squared equals c squared is now 3 squared plus 4 squared equals c squared. All right, because a is 3, so 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16 equals c squared. And then 9 plus 16 is equal to 25. The last step to get c by itself instead of c squared is going to be to square root both sides. So the square root of 25 is exactly 5. So you would get that c is equal to 5. So this right here is actually length 5, a 3, 4, 5 triangle. That is the first example. So sometimes it turns out very, very clean. Sometimes it does not. Here is another example. This is, I don't know, 4. This is 7. And let's find out what the other one is. So here I'll say, well, this is the hypotenuse we're missing. So we are looking for c. So I'll call this a and this b. I would have 4 squared plus 7 squared equals c squared. Because once again, a squared plus b squared equals c squared. We know a, we know b, we don't know c. 4 squared is 16. 7 squared is 49 equals c squared. 16 plus 49, you know, worst case scenario, you can always use a calculator. You guys have Desmos instead, but you can go to Desmos on LCPS Go and do it. But it's 16 plus 49, and as you can see, it is 65. So 65 is equal to c squared. The thing is, once again, in order to get c instead of c squared, is you have to square root it. But the problem here is that 65 does not have an actual square root whole number. I'll show you that. Second square root of 65. It is 8.0622577748 blah blah blah. The decimals go on forever, but you just only see this much. So two things can happen, and it's really just depending on what the directions of the question say. Since you can't really get a whole number, sometimes you'll literally just say the answer is the square root of 65, and that would be the answer. But sometimes in multiple choice, it just gives like an estimation, in which case 8.06, if you round it to the tens place, the 6 would round the 0 up to a 1, so I would put 8.1. Once again, that is an approximation. It's approximately 8.1, but one of those answers would be it, just depending on what the question says. It'll either say, give it as a radical, estimate it to 1 decimal point, or if they don't say, chances are either one is fine. All right, another example. Type. Boom, boom, boom. This one, I'll start throwing letters in there because, you know, that's what they did in algebra. So let's do that here. If this was 5, and this is x, and this is 13. Let's see if we can solve for x. This time it's different because this is a, this is b, and this is c. So if I use the formula a squared plus b squared equals c squared, a is 5, so I would have 5 squared. B is x, so I would have x squared. And c is 13, so I'd have 13 squared. And unlike the others, this time there's actually a number on the right side rather than a letter. So 13 squared is 169, and 25 is 5 squared. So this time you have to do a little bit more algebra. It's not just, hey, square root stuff and you're done. Because x squared and 25 are on the same side, you would have to subtract 25 in order to get 144 is equal to x squared. And if you don't believe me, here it is. 169 minus 25 is in fact 144. And then you square root that, which you know or you don't. Oops. It's 12. Exactly 12. So you square root both sides and you get x equals 12. And that would be the answer to your question. Okay. I'm going to put up a random question and see if you can figure it out. Let's go with 10y and 20. Woo! All right, go ahead, pause, see if you can get what y is. And we're back. Woo! So here we got a, b, and c. So we got 10 squared plus y squared equals 20 squared. 10 squared is 100 plus y squared equals 20 squared is 400. Then you would subtract 100 from both sides, and y squared equals 300. Square root both sides, and you get y is equal to the square root of 300, which maybe it's an answer. Square root of 300 is approximately 17.3. So I could also put 17.3. Depending on how much you remember of Algebra 1, you could actually technically simplify the square root of 300. I don't know if you care, but that separates into 3 and 100, which is 10 times 10, and there's a pair of 10s and a leftover 3, so it would be 10 root 3. Like I said, that's if you remember. If you don't, whatever. Just choose one of those. Cool. Okay, that's that for Pythagorean Theorem. One last thing, and we'll finally be done, is that you can also, they call it the converse. The converse of it is, instead of if you have a right triangle, then this works, you could instead say if this theorem works, then it's a right triangle. By that, I mean, like, if I had this thing and I don't label it 90 degrees, and I say this is 15 and this is 20 and this is 25, and I say, is this a right triangle? Well, the answer could be yes or no. If you look at it, it kind of looks like 90 degrees, but what if it was actually 89 instead of 90? What if it was 91 instead of 90? It would still look the same, but you just can't tell. But this says, the Pythagorean theorem says, if a squared plus b squared equals c squared, then it is going to be a right triangle. It's just kind of going the other way. So if this works out, then it would be a right triangle. So it's a yes or no question. I don't think I said this yet, but it should make sense after I say it. When you have a right triangle, the hypotenuse has to be the longest side. So keep that in mind. The hypotenuse has to be the longest side. There's kind of a visual way to prove it. The way I kind of think about it is, let's pretend that this was a house, the roof of a house. And if it was to cave in, if this was to cave in here, and that was to cave in here, you'd see that the lengths are just kind of longer than this one when put together, which means that, I don't know, I feel like I'm explaining that badly. But maybe just take my word for it for now. I can show you a proof later if you really want me to, that the hypotenuse is always the longest. Actually, it probably is easier from this angle. If this was to fall over, you can see that the 25 is going to be longer than that. And if this was to fall over that way, like that way, then it's definitely going to be longer than that leg as well. And that's true of any right triangle. If this was just to go, then that's obviously going to be longer than that. And if this was to fall over that way, then that would fall over here and be longer than that. So hopefully that's just a small visual way to know that the hypotenuse is always longest. Why am I saying all of this? Just so you know that the 25 has to be C if it is the C. And then this is whatever. So 15 squared plus 20 squared is hopefully 25 squared. And this is either true or false. So let's find out. 15 squared. 20 squared. 25 squared. 225 plus 400, because it says to add them together, is in fact 625. So you would go ahead and you would circle that big old yes, yes it is, versus just an example of something that would not be. Let's say that this is 5, 6, 7. Once again, this is the biggest one, so that has to be C. So I would do 5 squared plus 6 squared equals 7 squared. And you'd have 25 plus 36 is 49. In which case 25 plus 36 is 61, not 49. So it is not a right triangle. I'm just going to do right, okay. And there you go. Okay. And that's it. That's all we have to talk about with Pythagorean theorem. So we're arriving just under 20 minutes, which means you're probably bored of my voice. So go ahead and take a break, definitely, before you watch any more of my videos. Hopefully that was helpful. Yeah, that's it. Take care.